we're going to bring in two concepts and talk about how they can tell us a reaction and which way it will shift between an acid and a base. Now, one of the concepts comes down to dealing with what this Kc really means. So if you remember, this is going to be your products. Remember, they're raised to coefficients and all of them are times each other. And your reactants. And there's a few ways that we can say things about K. So what we could say is that if your products are the biggest part of the reaction, so high concentration of your products, then your Kc is going to be big. And in the least, we can say that it's going to be greater than 1 if that top number is biggest. There's another way to look at it also. And what it can also be is that if this number on bottom, we can say it the same thing in a different way. If this number on bottom is smallest. So you'll know that, like, if you take the number 10 and you divide it by 5, you get 2. But if you take the number 10 and you divide it by 0.1, you're not going to get 2 or any number like that. You're going to get 100. You can put this in a calculator and you can tell. So that's two ways that you can say it. You can say that when you have a high product or when you have a low reactant concentration. So that's one piece of it. We had talked about this before in some previous sections, but that's kind of key now. And the opposite is also true. So if the top number is the smallest number, so now if this is the smallest number, your Kc will be small. And your Kc will be less than 1. So if your products are small or low, and this time you can also say it as the reactants being big. Because when you divide by a large number versus a small number right here, a large number gets you a smaller final number when you're dealing with a fraction. And I can even say that if I take 10 and I divide it by 100, that's an even larger number than the 5, and it gives me 0.1. So you can see that these are opposites. So these were referenced before. We've talked about how Kc, like when it's small and when it's big. And the other thing is talking about conjugates. So when you have a reaction that looks like this, it looks really complicated and it's kind of hard to tell what's what. Like where's your your acids, where's your bases, and which one's doing what thing. So I'm going to try to make it a little bit easier. So I'm going to first of all find my pairs. So here's one pair. And here's my other pair right here. So I've got the pairs. And then I'm going to look and see, well, which one has more H's? So if I look at this right here, like the CH3 part, that isn't the part that does the reactions. The nitrogen's the part that does the reactions. So you can see right here, this one has 2, but this one has 3. So this one has more H's. So this means that between the two of them, here's your conjugate acid. And this one has to be your base, because the base is what would be accepting a proton. Now, if I go over here and I color code this set, and you can do this either way, and once you kind of see it one time, you're going to see that you're going to have an acid and base on each side. So now I'm going to look and I'm going to see what the thing is that's different. And here I have a 3. And here I have a 2. So that means that this must be my acid and this one must be my conjugate base. So if I take all of this information all together, I will have found my conjugate pairs. I will have determined which one has more protons. That's going to be the acid one. And we'll know that the other, and by other I mean the other in the conjugate pair, is the base. So the last step is to figure out which way will the equilibrium shift. So we mostly focus on a set when we're kind of looking at this, and we can also tell which acid is the stronger acid by which way it shifts. So let's look at that Kc. Is this a large Kc or is this a small Kc? So I'm looking at this number right here, and I'm especially looking at that exponent. What that means is that I have zeros and a whole lot of them after the decimal before I see that 233 number. I mean, I got a whole lot. I'm not really counting, but I should be showing a lot of zeros in there. That's a small number. So that K is less than 1. And as we reviewed, for having a K that's less than 1, it means we have a lot of reactants and we do not have very much product. So what that means is that the reaction likes to be on this side. It wants to be over here so that it is mostly reactants. And it doesn't have hardly any or very little product. So when we do this, we'll say that the equilibrium, that it lies left, meaning it lies going in the left direction. It's kind of a weird terminology, but it's a very common thing to say. So we just look at the arrow and it tells us which way it lies. And then also it tells us where the stronger one is. If it lies going this direction, and I'm comparing this acid to this acid, this one's got to be the one that's doing its job a lot better because it's pushing the reaction to the left. And as a little note, if you have an example where your K is greater than 1, then that means that it lies to the right, meaning it's mostly going on this direction where you are mostly products and you have very little reactant. And in that case, we would say that it lies right, and the stronger acid would be on this side because it's pushing in that direction.